In this video, I want to go over how I build my Docker images and how I deploy my services to Azure. If you've seen my project overview, you'll know I have two main services that I deploy, along with a Redis instance for each one. The two services are Orleans and SignalR. Both of them get deployed to a Kubernetes cluster, and that's what we're going to look at today. So I have two scripts I can run, one for deploying locally to Kubernetes and one for deploying to Azure. I think a good place to start might be the Docker file for each service. Both services' Docker files look pretty similar, and they're honestly pretty simple, but I wanted to call out one really important feature. So I build these services for both AMD 64, which is the PC I'm running on right now, and for ARM 64, which is what I'm using in Azure. One thing that really tripped me up in the beginning was getting multi-architecture builds working with .NET and Docker properly. Now what I was doing was trying to build an ARM 64 image from my AMD 64 machine, which is definitely supported, and I'll go over exactly how to do that correctly. But there's three ways that you could do that from Docker. And the first one is using emulation via QEMU, which is insanely slow. They even mention it down here. Emulation with QEMU can be much slower than native builds. Yeah, it was ridiculously slow, so I knew something was wrong. Now the second one is using a builder with multiple native nodes. I'm not going to get into that, but they're basically saying get another computer. And the last one is using cross-compilation with multi-stage builds. And that is exactly how you're supposed to do it with .NET. This is something that is specifically supported by .NET. If a programming language has good cross-compilation support, you can leverage multi-stage builds to build binaries for target platforms from the native architecture of the builder. And it tells you have to specify build arguments such as build platform and target platform. And once I figured that out, everything just worked. So in the Docker file, there's essentially two things you need to specify. You need to specify what platform you're being built on and what platform you're targeting. Now up here, I set up my base image on .NET ASP.NET 9. This is the image that the app will actually run from. In this from, there's actually an implicit target platform set. So you can see here this warning, setting platform to predefined target platform in from is redundant, as this is the default behavior. So you don't actually need this. Now in the second step, I'm building the project from .NET SDK image, and I specify here's the build platform, which in my case would be AMD 64 because I'm on an AMD 64 machine building this image. But when I'm doing my .NET restore and .NET build, I can specify my target architecture and have .NET handle generating the ARM 64 code. And the same thing in the next step when I publish. As long as I specify this target architecture, then everything just works. I get the binary that I need for whatever platform, ARM 64, AMD 64, whatever. And if we go over to my build script, which we'll go through, I can just call docker build, and then I can list the platforms I want to build, which in this case are ARM 64 and AMD 64, and it will just work. So I just wanted to start with that because that actually tripped me up a lot. That was probably the hardest part of this whole process, was learning the proper way to do multi-architecture builds with .NET and Docker. I've never actually had to do it. Most jobs I've been in, we didn't really use ARM 64, but I'm trying to save some money. All right, now we can go through the Azure deploy script. So first I just set a bunch of variables, what resource group, where's the location, storage account, cluster name, blah, blah, blah. Next, I have a little helper function, which basically just checks if the last thing that ran worked, and if it didn't, then stop everything. All right, so step one is to log into the Azure Container Registry. So I need to build my image, and I need somewhere to put it. So I need to make sure I can log into this container registry. And this will prompt me for my Azure credentials if they time out. So I grab the ACR login server, I log into the container registry, I define my image names, so these are going to be the two images I'm going to push. And then I run that docker build command, which we already kind of went through. So I just specify the Docker file, the context, and the tag. This is honestly probably more context than they need, but it's a small project for now. It's, probably could be optimized. Then I just push both the images and I deploy to Kubernetes. So kubectl apply, and then I have my resources defined in this deploy folder, and I recursively apply every file in that deploy folder. And then I restart the deployments because sometimes when I deploy, nothing will have changed for one of the services, but I like to just make sure that everything restarts. All right, and I guess the last thing we can look at quickly is the deploy folder. So here's the deploy folder. I just have it split up kind of by service. So I have Redis, which is really the Orleans cluster management Redis. Then I have SignalR Redis, which is for the like SignalR backplane communication between instances. Then I have my SignalR service and my Orleans service. So I just look at one of these. They have a bunch of stuff like a role binding, service account. A lot of this stuff is just like permissions nonsense, which was kind of a pain to figure out. But most stuff is kind of defined in this deployment.yaml, which defines the actual deployment, how many replicas we're going to deploy. So I just have it set to 2 right now. I set the platforms that this service can tolerate. And then one cool thing here is you can actually set the scale set priority. So in order to run this service on a Azure Spot instance, which I'll talk about more later, but it's basically a cheap instance, you need to actually explicitly say, I'm willing to be on a Spot instance. Otherwise your pod will never get scheduled to that node. All right, so here we have my AKS cluster, and you can see there's actually nothing deployed to it. So this is all default stuff in the kube system namespace. So what I can do is I can run my deploy script, it'll build, and it should send it off, and we can test it out. So I should just have to run this, and it should just automatically work. Alright, so it successfully built both images, pushed them to the container registry, and applied our Kubernetes deployments. If I come over here and hit refresh, here you can see idle Orleans, 2 of 2, SignalR, 2 of 2, Redis, and SignalR Redis. And they're deployed. So let's make sure it works. So in the game, in the project settings, I actually have a configuration so I can set the different endpoints. So I'm going to set it to Azure. It's already set. And then if I hit run, and it is working. And another thing we could check is the Orleans dashboard. So I can see I've got players. I should have 2 players active. So like if I go to player controller, I have 2 activations of player controller. And if I go to, let's say, movement, so this move to tile function, if I like spam click, then you can see I'm getting, 6 requests per second, something like that, as I click around. And you can see I'm running on 2 silos, which means I have 2 servers, which matches the number of pods I have. So like if I go to get, so if I get the pods, you can see I have 2 idle Orleans. All right, so our deployment worked. And basically every time I want to make a change, I make some code change, and then I can just run Azure deploy and it'll show up on Azure. I can also just run a local deploy and it will show up on my local Kubernetes cluster in Docker Desktop. So nice that it's kind of the same thing. So I figure one more fun thing might be to do a little load test. So right now I have one node pool set up with 7 nodes in it. It was 8, but that's the fun of a Spot instance. They can go away at any time. So these are 8 core, 16 gig ARM64 machines. They, as Spot instances, cost roughly 5 cents an hour. Actually, if I West US 2, I don't think that actually changed anything. Yep. So annually, only $420, which is a steal. And I'm running 7 of these. So that means quick maths is this is about $3,000 a year worth of servers. And one thing that's nice is you can mix and match, so I could have bigger and smaller nodes and for different purposes. Yeah, that's a level of customization I haven't really gotten into though. All right, so here I am in the game. I set up a little load test. You can see I hit 1,000 players and things are doing just fine. And now what's interesting is that I'm only running on 2 silos. So even though in my cluster I had 8, now I have 7, but I'm running on 2 silos. So that means there's actually only 2 pods across all these. So what I can do is, let's say I want to scale up to 6, and let's go ahead and add some more. Let's see if I can do 1,500. And you'll see that these new 500 get spread pretty evenly across the silos. And we should start seeing them pouring out of the center. I changed my load test so that they don't all spawn and all start moving all at the same time. That does cause some problems. And yeah, I mean, this is definitely not smooth, but definitely starting to get some major lag here. Yeah, so I think probably what's happened is that all the zones ended up on one silo. So it's just getting hammered. 7 zones all in one silo. Yeah, I mean, that's going to do it. I bet if we run this experiment again, these guys should all log out. Couple zones that I guess I didn't get the memo. Definitely a best effort Yeah, there we go. Finally came through. I guess I have to restart. There's no other way for me to rebalance. I love how quick that is. So they're a little bit more evenly spread out now. There's still one zone with 3 activations, but should fare a little bit better. So let's try it again. See if we can get back up to 1500. All right, that's the first 500. All right, here comes the second 500. Everything seems okay. We have one silo that's a little beat up. All right, let's do the last 500. So far, so good. I don't see any signs of things blowing up. I think at some point I'll have to do like sharding, but I really wanted to see like what's the limit of the number of users I could fit on the screen. And if anything, it's like less about what will actually be in some future game if this ever turns into a future game. It's more about like if I can handle 1,500 people on the screen at the same time, and I'm not really saying this is like successfully handling it, but you know, if it can struggle along 1,500 people in the same area or, you know, the same few areas, that's a sign that things are okay. Like if I can then shard it out to 100 people a zone or something like that, you know, the tech is working. Yeah, all right. Sometimes logging everyone out can break stuff, so let's, yeah. This is a bug with the Redis backplane timing out, I think. Yeah, I need to like lower the timeout or something. These guys will disappear at some point. There you go. Alright, so that's typically how I build, deploy the game, and just stress test it. If you have any questions, leave them in the comments and subscribe to follow along. Thanks.